Welcome. The Office of the Chief Data Officer and the Texas Department of Information Resources are pleased to offer this course, Introduction to Data Architecture. In this course, we will define data architecture, describe some of the artifacts created through data architecture activities, describe some key roles and responsibilities of individuals involved in data architecture, and discuss some challenges and best practices when approaching data architecture initiatives. When people hear the word architecture, they tend to think of the art or practice of designing and constructing buildings. But dictionaries agree it also has another meaning. Architecture from an information technology perspective relates to the design of the structure of computer systems. Enterprise architecture provides a high-level view of the people, processes, applications, and data of an organization, described in a business context with the goal of maximizing value for the organization. It helps organizations understand the current state of their systems, promotes desirable change toward a future state, aids security access and control processes, assists regulatory compliance, and improves effective use of data by setting standards and guidelines. Enterprise architecture is comprised of different interrelated and collaborative domains: business, data, application, and technology. Each domain is responsible for a different aspect of an organization's data structure. In this course, we will focus on data architecture. So, what is data architecture? As an essential component of data management, data architecture describes how data should be structured and organized, how data should be integrated into business processes, and how data should be controlled so it can be effectively managed and used by an organization. According to the Data Management Association International's Data Management Body of Knowledge, 2nd edition, the purpose of data architecture is to identify the organization's data needs and to design and maintain master blueprints to meet those needs. Data architecture enables data to be treated as a business asset that can support the needs of the organization by ensuring alignment between business strategy and data investments. Data architecture helps bridge the gap between business strategy and technology execution by translating business needs into data and system requirements. It defines standard terms, definitions, and development specifications to enable consistent data standardization and integration across the organization. It ensures designs for new developments align with the existing enterprise-level data architecture blueprint or framework. Data architecture also makes sure business rules and data flow are consistent and traceable. Data architecture interacts with the other architectural domains in an organization to create the framework for managing data. However, each domain has its own purpose, elements, dependencies, and responsible roles as they relate to data and its business impact across the organization. Business architecture identifies how an organization creates value for customers and other stakeholders and establishes requirements for the other domains, such as what data is a priority and what business roles apply. Data architecture organizes and manages the data created and required by the business, and describes where and how the data is stored. Application architecture determines the structure and functionality of applications according to business requirements, so data can be accessed and used. And technology architecture hosts and executes the physical technology and infrastructure needed to enable applications and systems to function and deliver value to the business. Each domain influences and puts constraints on the other domains. They depend on each other to create efficiencies and provide value to the organization. Therefore, architects from these different domains must work together in the development of requirements to ensure alignment with the organization's overall data strategy. Data architecture is often used when developing new projects and infrastructure or with updates to existing systems. For example, data architecture is involved when defining individual project data requirements to satisfy business needs, such as self-service reporting and regulatory compliance. Reviewing project data designs to ensure data models are consistent with the data architecture framework and long-term organizational strategy. Determining data lineage impact so that business rules and data flow are consistent and traceable. Ensuring sufficient and appropriate data replication controls are in place to achieve consistency across the organization. Determining rules for how data exchange processes should be structured, organized, and implemented to ensure accuracy, consistency, and adherence to organizational data requirements. Guiding data technology and renewal decisions to help manage the versions, patches, and policies each application uses. And enforcing standards of data architecture principles, procedures, guidelines, and blueprints, including expectations regarding compliance with those standards. Data architecture activities consist of the development of several essential elements or artifacts. At the enterprise level, data architecture defines standard terms, requirements, and designs for the data that is important to the whole organization. Data architecture activities create artifacts to describe the existing state of data architecture in the organization, define data requirements, and guide data integration processes. Data architecture design documents provide standards that govern how data is collected, processed, stored, distributed, used, and removed in the organization. These documents describe the systems that handle data, as well as the paths data takes through those systems throughout the data lifecycle. The most detailed data architecture design document is the data model. Data models provide a common vocabulary around data and are the main medium used to communicate data requirements from business to IT and within IT to database designers and developers. An enterprise data model describes an organization's data and systems overall as the organization understands it. An enterprise data model contains data names, comprehensive data and metadata definitions, and business concepts and rules. It describes relationships between all data models throughout the organization and documents high-level data exchange and interoperability requirements. It may also lay out plans for meeting current and long-term data requirements. An enterprise data model sets forth the foundation for all data and data-related projects within the organization, and any business-specific or project-level data model must be based on the enterprise data model. However, data architecture specifications within different lines of business in the organization may have additional requirements defined in the business-specific or project-level data models. While describing data modeling and design in detail is beyond the scope of this course, in general, data modeling is the process of discovering, analyzing, and scoping data requirements, and then communicating these requirements in the form of conceptual, logical, and physical models. A conceptual data model captures the high-level data requirements as a collection of related business concepts. A logical data model captures the business rules of a business process and is a detailed representation of data requirements, including application requirements. A logical data model is an extension of the conceptual model. Physical data models capture the details of a specific technical solution and are developed using the logical data model as a starting point. Data architecture activities also result in data flow designs and mapping specifications. Data flow designs document the movement of data throughout the data lifecycle and may represent different levels of detail, such as subject area, business entity, or attribute level. They map and document the movement of data from its source to where it is stored and used. Data flows document where transformation processes occur and locations where differences in the data may occur. Data flow designs also document data-related business roles, depicting which roles have responsibility for creating, updating, using, and deleting data. A mapping specification, or data map, is a more detailed document that defines the movement of data from one source to another target source. This ensures smooth transitions or integrations and avoids data inconsistencies. A mapping specification document lists the individual data attributes from the original source of data and maps them to a corresponding list of data attributes for the target source, such as a data warehouse or repository. The document describes transformation rules of what needs to happen to each attribute as the data moves between systems, such as default values or formats, which data fields may need to be combined in the target source, and any other logic needed to successfully move data from the source system to the target system. Mapping specifications provide an opportunity to discover and resolve data issues prior to implementation, including potential issues with the data models, and can help improve accuracy and completeness of data. Data architecture artifacts also include data definitions. Developing and documenting standard data definitions reduces ambiguity, improves data quality and data integration processes, and improves communication overall, both between systems and between people. Data architecture activities can produce draft definitions, but all terminology should be vetted and approved by subject matter experts within the organization. To be most useful and effective, data definitions must be rigorous in wording and explain any exceptions, synonyms, or variants. Definitions should be precise, easy to read and grasp, and contain simple, well-written sentences. Acronyms should be avoided, and instead of using ambiguous terms such as sometimes or normally, define what the exceptions may be. Finally, definitions should be complete so that all parts of the definition are present. For example, when defining data containing a unique identifier, a description of the scope of uniqueness is included in the definition. Or for a data element that has different variable codes, all appropriate code values are included in the definition. Different roles within the organization have different relationships with data architecture and provide different perspectives. We will describe a few key roles here, beginning with some of the technical roles. The technical role that may have primary responsibility for data architectural activities is the data architect. As defined in the Data Management Body of Knowledge, data architects document and maintain organizational knowledge about data and the systems through which it moves. This knowledge enables an organization to manage its data as an asset and increase the value it gets from its data by identifying opportunities for data usage, cost reduction, and risk mitigation. Data architects help prepare the organization to quickly evolve their products, services, and data so it can take advantage of business opportunities inherent in emerging technologies. For example, data architects translate business needs into data and system requirements to help identify the most appropriate emergent technology that will provide the most value. Data architects define and maintain specifications related to the current state of data in the organization, and make sure processes consistently and accurately provide the data necessary for strategic use. With input from the business side of the organization, they document a standard business vocabulary for data and its components and promote alignment between the organization's data strategy and business architecture. One specific role an organization may have is an enterprise data architect who manages complex data and information delivery throughout the organization. Enterprise data architects outline high-level integrated designs to meet strategic data requirements, including integration with the overall enterprise architecture roadmap. This role is responsible for overseeing the holistic data architecture for the organization, including data models, data standards, and data integration guidelines to manage complex data and information delivery throughout the organization. The enterprise data architect works with both business and technical stakeholders to facilitate alignment between the business and IT. This collaboration ensures that systems implementations align with key business rules and needs. Your organization may have an enterprise data architect responsible for the overall organizational perspective, and individual data architects who are responsible for data architecture activities within its separate lines of business. Individuals in a data modeler role are responsible for capturing data requirements, data definitions, business rules, and data quality requirements, and for developing conceptual, logical, and physical data models based on that information. As business needs change over time and new technologies are developed, data modelers also review and maintain the data models and make any necessary changes. They work closely with data architects and database administrators, as well as with the organization's data management team. They may also work with end users of the data to make sure data systems are developed according to their needs. There are other technical roles that play a part in data architecture activities, and those roles often have technical data stewardship responsibilities. Their job titles may include data integration specialists, application developers, database administrators, business intelligence analysts, and data analysts. Effective data governance and data management requires collaboration and coordination between the business and the technical domains. Individuals in leadership positions within the business domain are responsible for identifying how the organization creates value for customers and other stakeholders. They understand business processes and how data can be used for strategic advantage, and therefore determine necessary business requirements for optimal data flow within the organization. In addition to individuals in business leadership positions, other roles within the business also have a hand in data architecture. Staff in a tactical role are those who may be responsible for leading a single business unit, and they rely on data to make sure the program is running smoothly. Sometimes these staff have a cross-business function or an enterprise-wide perspective, and they may have a vision for how interoperability and data integration across systems and platforms can be used for strategic advantage. Staff in a tactical business role may be responsible for documenting data classification rules, compliance rules, or business rules for the data under their domain. They are also responsible for making certain the rules are communicated to all relevant stakeholders, including data architects and data modelers. A critical business role is the data steward. Operational or business data stewards are active within the business unit and can be recognized as business subject matter experts. They understand the organization's business processes and the impact program decisions have on the data and the ability to provide responsive information to the program. Data stewards are typically not hired into the specific role of data steward, but are existing staff who already have detailed knowledge and expertise about the data in their area. The focus of data stewardship is often on defining business terms, data definitions, and valid values for their subject areas. They may also define and maintain data quality requirements and business rules for assigned data attributes, help identify and resolve data issues, and provide input into data standards, policies, and procedures. Data stewards are often the communication line between the business or program departments and data architects in the information technology department. Therefore, it is a best practice for staff in this role to have a good understanding of both the business side and the technical side of the organization. There may be other business-based knowledge workers, such as business or process analysts, who contribute to ensuring that business process models and the actual processes that create data are sound and support downstream uses. There are other key roles within the organization who are also typically involved in data architecture activities. Data architecture activities often fall under the responsibility of information technology professionals. However, data architecture is a component of data management, and therefore the organization's data management officer is responsible for making sure data architecture activities align with business needs and the overall data strategy for the organization. Information security officers are responsible for ensuring controlled access to data requiring different levels of protection. Information security professionals are often tasked with managing IT compliance requirements, policies, practices, data classifications, and access authorization roles across the organization. Information security officers and their staff are therefore responsible for making sure data architecture activities align with data security requirements for the organization. Privacy officers, or others in the organization's legal department, are responsible for knowing and understanding all the data protection laws and regulations that are relevant to the organization and ensuring the organization complies with those laws and regulations. Individuals in this role are therefore responsible for making sure data architecture artifacts include adherence to data privacy requirements. Records management officers and their staff are responsible for documenting and enforcing records management and retention schedules, including data stored in various types of media. Individuals in this role are therefore responsible for making sure data architecture artifacts align with retention and disposal requirements for the data owned and managed by the organization. Individuals in leadership positions in these supportive roles often work closely with leadership on the business side of the organization and with each other on data governance initiatives such as data architecture. This collaboration ensures alignment with the organization's overall mission and goals. You can find more information about the various roles and responsibilities in data governance in the Texas Data Literacy Program course, Data Governance Roles and Responsibilities. Data architecture initiatives, like any other data management initiative, may face certain challenges that can hinder success, especially when it becomes a priority for the organization's data governance and data management strategy. Data architects and data management officers may experience a lack of support from senior and executive management or have an apprehensive sponsor for the initiative. Individuals in these roles should help stakeholders understand the value that data management and data architecture in particular brings to the organization, and they should encourage stakeholders to become familiar with data architecture processes and deliverables. There also may be resistance to an overall enterprise-wide approach because different lines of business have different needs and priorities for their data. Data architects and data management officers must be clear in communicating the importance of enterprise data architecture and establishing appropriate standards to meet the organization's overall needs. However, data architecture standards should allow some flexibility for individual lines of business. There may be resistance to prioritizing data architecture initiatives because there is no proven record of accomplishment. Data architects and data management officers can develop use cases to highlight how current data issues impact the organization and to describe how data architecture activities and artifacts can improve those data issues. The success of data architecture within an organization also depends on several factors focused around organizational and cultural change management. Organizational change management can help an organization take a structured approach to communicate the benefits of the management and use of data, engage stakeholders in the decision-making process, address potential concerns, create awareness, and clearly define the necessary resources and processes to support initiatives. A formal enterprise-wide approach to data governance, such as the establishment of a data governance council or other strategic body, is a key step towards success. Cultural change management involves changing values, behaviors, and practices within an organization to help align the organization's data culture with its mission and goals. Data literacy initiatives or programs are one way to promote cultural change. Data literacy education can help senior and executive management recognize that data is a business asset, not just an IT concern, and understand the concept of data architecture and the value it provides to the organization. Data literacy education can help data stewards and others in the business understand how their expertise fits into data architecture activities. It can help project managers understand why and how data architecture activities are essential components of project plans. Finally, data literacy education can also increase stakeholder confidence and trust in the decisions made by data architects and the data management team. Data architecture is an essential component of data management. Data architecture describes how data should be structured and organized, how data should be integrated into business processes, and how data should be controlled so that it can be effectively managed and used by the organization as a business asset. Data architecture works with the other architectural domains to ensure alignment between business strategy and data investments. Collaboration across the domains is critical for alignment with the organization's overall data strategy and the success of data architecture initiatives. You have now completed the course Introduction to Data Architecture. In this course, we defined what data architecture is, described some of the artifacts created through data architecture activities, described some key roles and responsibilities of individuals involved in data architecture, and discuss some challenges and best practices when approaching data architecture initiatives. For more information on data governance and data management principles, visit the Office of the Chief Data Officer website.